This is the Multiple Sclerosis Haptic Explorer. It's an educational VR experience that we recently developed, and it uses haptic feedback as a way of letting users experience what neuronal signaling might actually feel like. Hi, I'm Kevin Miller, Senior Vice President of Creative and Medical Science. A large part of our R&D initiatives focus around new ways to tell stories that combine technology and compelling visuals. We're continually exploring the role that VR can play in immersive storytelling. More recently, we've begun examining the potential for haptics or tactile feedback to enhance these experiences by making them more engaging and memorable for users. In this case, we wanted to not only show the changes that occur within the brain for patients with MS, but also let users feel this difference as the disease progressed. The haptic technology we selected were gloves made by BeBop Sensors. One size fits most, and wearing the gloves is fairly easy. Once you slide each finger into the sensors, you secure the glove with a strap. At that point, you'll need to calibrate. There's a 9-degree IMU module in the gloves to capture position and movement data from an accelerometer, magnetometer, and gyroscope. These can all be used with the sensors and controllers from your VR system for low latency accuracy. While that covers inputs to the glove, there are 6 actuators that provide the actual sensory feedback to different points in your hand, one for each finger and one for the palm. The haptic sensation is generated by adding waveforms to different objects within the scene. When a person interacts with a 3D object that has an associated waveform, the actuators vibrate. The intensity, pattern, or cadence of this can be controlled by the developer, leading to a huge number of potential senses you can deliver to a user. We selected multiple sclerosis as the focus of our program because there are many parallels between neuronal signaling and the sensory feedback provided by these haptic gloves. Here, we have one of the scenes we built in Unity. It shows neurons firing in the brain. While neurons normally exhibit a regular pattern and intensity when they're active, impaired neuronal function in patients with MS leads to disrupted and irregular signaling. Not only does the narrator explain what's happening, but users can reach out and actually grab a neuron so that they can feel the sensation. As the disease progresses, the steady, even signaling is replaced by aberrant and irregular pulses. Being able to feel this difference not only helps in creating understanding, but it makes messages more memorable.
Hi, I'm Mark Beelan, Creative Innovation Associate. The COVID-19 pandemic has brought so many challenges and changes to our work processes. We were met with a particularly big challenge. How do we develop a tactile experience in a virtual and remote work setting? Overcoming this challenge required new ways of working. We migrated to virtual conferencing, we partitioned our brainstorming sessions to individual team members, we injected more revisions and checkpoints in the development process, and we coordinated with local public health protocols to be able to demo and finalize our haptic VR experience. We even passed one working glove between team members in the development phase to minimize physical contact. You can appreciate that with these modifications in our workflow, our development took a little bit longer than expected, but we were able to overcome the challenges and produce an engaging educational experience that reminds us of the value of touch in a touch-conscious world.
While we're excited to share more of this work, we're also excited to share more of these videos. In the future, we'll examine other technologies and show how our R&D initiatives are making their way into other client projects. So if you'd like to be notified, here are a few places where you can follow us.